Hope you all have been submitting the weekly assignments weekly or regularly. So without any further ado, let's start the session. Welcome to the final session, the 13th session of problem solving through programming in C. I'm Aditya from IT Madras. So on the class we had on Sunday, during the session we had on Sunday, I did a recap of week 12, so I'll not be going through it much. So structures and type def. So we used type def to define structures, and then pointers were covered in detail. Of course, pointers in structures and array. So pointers were introduced in a way, pointers were introduced when arrays started. So pointers was first introduced when we had to pass an array through a function, and we had to sort an array, etc., etc. So then dynamic memory allocation and file handling. So it's all the. I didn't go through the recap in much detail because I did that day before yesterday already. So yeah. So first, let's start with one code from dynamic programming. So I have this code which uses pointers and also malloc. So malloc is memory allocation. It dynamically allocates memory to the elements of the array. Okay. It dynamically allocates memory wherever we need it. Okay. So this is, so I want the output of this code, and I'll give you maybe 3 minutes for this. I've written 5 minutes, but if you're done in 3 minutes, then it's good. So at the end of 3 minutes, I'll open the chat and you guys can answer it there. Fine. Okay, so let's just look at the answer. Uh, So no one had answered, but oh, I'm really sorry, I forgot to share the screen. Yeah. So yeah, so I have written the code and the output is 0, 1, 2, 2, 3. So how we got that? So first I'm starting with an integer I, then I'm initializing a pointer p and I'm allocating it 5, I'm allocating it a space required by an array of 5 integers. Okay, so size of int, that is 4 bytes into 5 malloc int star. So int star I have to mention because it's a pointer here. So I am allocating it memory worth of 5 integers. So an array of 5 integers, just assume that, and in that memory location, in that address, I am storing the array 0 1 2 3. So yeah, 0 1 2 3 4. That is what this for loop does. So since there is only one line inside the for loop, I didn't add the curly braces. So it says if my address, let's say address was 2000, okay. So you know that when I do pointer plus, will it do scaled addition or just addition? So scaled addition is when I increment it, and depending on what kind of pointer it is, it will increment in that way. So if it is an integer pointer, then incrementing will increase it by 4 spaces. Okay, so here there is scaled addition. Okay, so yeah, scaled increment is going on. So so my array is now 0 1 2 3 4 5. So the first one, not the zeroth one, in the first one I'm storing 0, then I plus plus is happening, and in the second space I'm storing 1. So like that I have from 0 to 4 an array of 5 integers, through which I have dynamically allocated some space in my computer, in my memory. Okay, so then I print it. So when I write star ptr plus plus, first of all it is post increment. So it will print the first element, so of wherever this pointer is pointing to. So first element is 0, that is why I have 0. Then it is post increment, so it has been incremented, and even this is post increment, and these two basically mean the same thing, because star has precedence over plus plus. So this is for you to fact check once. I said star has precedence over plus plus, but if you think it is not the case, then you can just type in the comments. It is also to test your memory. Okay, so yeah, I think highest precedence arrow key has, arrow, that hyphen and greater than sign. Okay, so so this will print 1, then since it's post increment, after printing 1 it will increase, it will start pointing to the next place, it will point to the next place. So next is 2, 0 1 2 2, so 2 will get printed. Okay, here it is still 2. Why is that? It is pre-increment, but it is still 2. So that is because it is, the pointer is increasing, the address is not moving anywhere. Okay, so it is 4 bytes, it is going to the next one, it is still at 2, it is still pointing towards 2, because it's just one space, right? So if I change it to this thing, wait, okay, so adding brackets here will not help. Right. Uh, sorry. Yeah, it's the same thing. So it is being pointed. So it is still pointing at 2. Then when I come back here, I am increasing the, I am doing plus plus on this whole thing, on the pointer itself. So now it will go to 3. Okay, so it stays at 2. After that it will go to 3. Okay, so this was, I think, fairly simple. Yeah, I hope the screen is visible again. Next is arrays and pointers. So I have this another fun code where I initialize an integer, sorry, when I where I define a function and pass an array. So what is the output? Okay, so look at this code carefully and tell me its output. I'll close the chat. And so I started the timer for 3 minutes. At the end of 2 minutes, I will open the chat and I request you guys to type in the answer if you have solved it, because this is, this shouldn't take 3 minutes, but for you to read the question once, I'm giving 3 minutes. So I've got one answer, that is 8, 10, 13. So let's check if it is correct or not. Yeah, so two people are saying 8, 10, 13, and incidentally the time is also up. So ten, 13, 12. Oh, okay. Let's see what the answer might be. Sorry. Maybe I should have taken this time to write the code. So as most of the answers said, it is 8, 10, 13. So for to quickly explain, you might have noticed in the slide that I showed where the question was that I wrote arrays and pointers. So which is a pointer here? So this ARR is basically a pointer, right? So this pointer, it is when I pass the array, it passes its address. So ARR is a pointer that is pointing at the first element of the array, first as in 0th, right? That is 10. And when I do ARR equals ARR plus 2, that pointer has moved to the third element or the second element. I mean 0 plus 2 is 2. So the technically third element. So it will print 8 here, okay. So first, since this function has been called, it will print 8, but only the pointer's value has changed. The array itself, there is no change. So there would be change in the array if I change some element. Let's say I declare some variable I and I write array of I equals 1 plus array of I, something like that. So arrays are passed by reference, but here I am only changing the pointer. Okay, this will only change the pointer because I have not mentioned any boxes to state that it's the array I am wanting to change. So the array itself is unchanged. Okay, so here first element is still 10 and second element is still 13. Here I moved the pointer by two places as in, of course, they are integers, so it will move appropriately. That is why it is printing 8 here, and here I will print 10 and 13. Okay, I hope it was clear. Someone said 10, 13 and 12, so maybe they got 10 because 8 plus 2 is 10, I am not sure, but anyway, sorry, oh then 10 plus 2 should be, anyway. So if you have any doubts, you can type in the chat or raise your hand and ask, else I will move to the third thing. So this is done, relatively easy, easier than the last one, of course. Then so in week 11, I gave you a task of writing a function to reverse a string using recursion. Okay, so then when I explained, I mentioned stuff about static int, static char, etc., etc. So this time I give you an option to write it anyway, and it's up to you if you want to use the static kind of variables or not. And once this is done, I'll also explain why I used the static variables. Okay, so and I'll give you one hint. So hint I haven't written. So that one hint I want to give is, you might remember from week 11's lectures that these this recursion, the way the recursion calls happen, it's like whatever I call the last will get executed first, right? So it is like a stack. So that is your hint. Okay, so that is one very easy way to reverse a string if the only goal is to print the reversed string. Okay, so 10 minutes should do. So yeah, and people who attended week 11, they might feel a little bored, but I see like a few new people, and even so you guys can try the variation without the static variables. people who already attended week 11. So you can try doing the variation without the static variables. The time is up. I hope you guys had a chance to try it out. So I'll solve this in two ways. So first, for the first one, I already wrote the code when to save time. I wrote the code when you guys were trying. Second one, I'll write in front of you. This is also what I did last time. Okay, I still have to write the main part. I will just give me a second. Okay, so I'll take 2-3 minutes and explain the code. So first I'll go through the main one. So in the main code, first I'll tell you this hash defined max len is 100. So this is the 100 is the maximum possible length of a string. Okay, so it is kind of a global variable. So 100 is the maximum possible length of a string. So wherever I use max len, it means it's 100. Okay, so str max len, and rev is a pointer that points to that string, points to the address. I mean, it's another string. Here I didn't mention any length, but you will know why in a second. So I ask the user to input a string, and I scan that using scanf. Then I call this function srev. So srev is a function for reversing the string, and I have written since rev is a pointer. I mean, since it returns a pointer, right? So it is returning rever, and I'm storing this in rev. That is a pointer. This function itself is a pointer character. Okay, so not a pointer character, a character pointer. So this will, So and then I take the input of the main string, or the string the user has input. Then I declare rever. This is and I as static char and static int. So this is a string of course whose maximum possible length is max len, and I have initialized it as 0, but I have given it static. So when it comes back to this line during recursive calls, it will see that it will reinitialize I. You know what I mean? So it will not reinitialize I. It will only in the first call I is 0, and since I am having I plus plus here, I am doing I plus plus here at each recursive call. Since of course there is a recursive call here, right? Srev. So during each recursive call, i's value will constantly increase. It will not get reinitialized to 0. So that is a use of static. Okay, and static char also, since I'm traversing the string, I don't want the string to come back to whatever I start with, that position. So yeah, so this if loop, if star str means as long as it is pointing to some meaningful character. Okay, so it's not \0. So if it is pointing to some meaningful character, I'll call it again on the next character, right, str plus 1. So str is a pointer, it's not a pointer, but here when I do str plus 1, that we did an array problem in the beginning of the class, task 1, right. So when I just do this, that means I am moving it by one space. I mean, it was pointing at the first or the 0th element. When I do plus 1, the pointer will move to the next element. Okay, so on that part of the string, I am calling the array. I am calling this function, and I am storing this rever. So star str means the first, it's first element. Okay, so if I don't write star, it will mean the whole string, and I can't just copy it to one element, right? So that would be wrong. But when I use star, so with arrays and strings, they are passed as, I mean, string is an array, character array, so they are passed as references. So star str would just mean the whatever is there, the value stored at the first address. Okay, or not the first address, yeah, the first address. So here my input, I'll actually run the code and it's more helpful. Hello there. Oh my god, can't even backspace now. Oh, I can. Hello there. I misspelled hello. Whatever. Reverse string is, oh, so it because I did backspace, it. Okay, wait. Strings. Whatever. Okay. So it has reversed the string. Okay, I have to check if it incorporates blank space as well. I think that will be when I change this to that in square brackets I have ampersand, sorry, I have the exponent sign, the power sign and \n. For now, when I hit space, it terminates the string there itself. So I have to change this, that's all. Okay, so yeah. So here so in the first call, for the first call, this thing is S, just S, the first S. But before reaching this line, it is calling itself again, right? So recursion is going on here itself. So that way it will reach the last of the string. I mean, it will keep calling, it will reach the end, and at one point this if will not get satisfied, okay, because it has reached the end. Then it will come here. So for the last one, it will come here, and I plus plus is going on, right? So so str, so I am moving the address by one space now, just by one space, okay. And since this rever is a static character, so it, I mean, so whatever I am storing here is getting stored, and whatever I store next will be the next character. So the characters are not getting overlapped with each other. So if I store S and next is G is not getting stored at the same space, it is getting stored at the next location. Okay, so first, since I'm calling it recursively, first it will read n, I mean sorry, not read n, it will read strings, while but while processing, it will first process the last s, because after that this I reach the base case and this recursive call will not happen anymore. So the first element in REVR is s, that is the last element. Okay, so when I run this thing for the last time, that is when I reach this line for the first time. Okay, I didn't reach this line at all, because I was just calling the function again and again. Okay, so once that thing has been reached, it is stored, s is stored as the first element in the array, and post increment happens, I gets incremented by 1, and then it goes back one step, right? So that is how recursion happens. Whatever is called the last, that happens first, then one by one we backtrack and all those things happen. So then G gets stored in rever, then same way IN, I, R, T and S, they get stored one by one in a reverse order. So it's similar to a stack, like, right? So I'm just using the fact that recursion happens like that. Okay, Shreya Prasad has raised her hand. Do you want to say something?
Having a doubt.
Yeah.
When the control comes out of the function definition, will I and the REVR array get destroyed?
So if it is getting, let's see, let's see. So I'll just, I think the scope of this is only this function. So it should get destroyed. So, but I'll still check. I'll write printf uh, percentage d I. Okay, since the scope is this function itself, it should not remain. Yeah, see this I is undefined. So after the last call, it is getting destroyed. I and REVER.
Yes.
Okay, I hope that was clear. So yeah, I'm basically just storing this in a reversed fashion, and I'm not intentionally doing that. Recursion is helping me do that. Okay, so just for, so this might have been a little complicated. So what I'll do is I'll also write the same thing without using pointers. Okay, so I will stop sharing this. So because pointers, at first it is a slightly complicated thing to grasp. So if, I mean, and they can't explicitly check if you've used pointers or not, and in some places it is without pointers you can't write. But here that is not the case, so I can write this without explicitly using the star symbol. I mean, yeah, pass a if I pass an array, I am indirectly still using pointers, but I'll not be explicitly using that star symbol. Okay, so I'll use the fact that uh, I'll use the fact that arrays are passed by reference, and my function. So wait, I'll also use string functions. String dot h. Right. So I'll call even this srev, because why not? So I'm not sure if I can use end. I mean, I think I can use end to be. I mean, I can use end as name of an integer. It should work. Okay, I'll do it without that. Then I'll change the name to end, and we'll see if it works. Fine. So basically, what happens in reversing a string? With recursion, we just stored the string in a reverse way and outputted. But if I don't want to use functions at all, I'll basically just swap the first one with the. I mean, if I want to reverse the same string and I mean store it as the same string. If I'm storing it as a different string, then I'll just store this same string in a different variable. I'll store it in a reversed way. I mean, I'll start from n is equal to max length, not max length of the string, and I'll length of the string -1. I'll go till 0, I minus minus. I'll just copy the string. I can do that, but if I want it to store in the same string without that, I mean, if I don't want to bring in a new string, then one way to reverse is to swap the mirror element. So first and last will be swapped, second and second last will be swapped. So that is a logic I'm going to use here. Okay, so yeah, first I need a base case. Even here I will be using recursion. So if first exceeds last, then of course I mean, no use. So this is the base case. That means I have reached the end. I'll just return. I mean, I'll just exit the function. Okay. Sorry. And now for the actual thing. So like I said, I'll swap. So I'll have I'll define a temporary character, which is my first element, and then of course str. So basic swapping. Sorry. Right, so basic swapping. Then to proceed, right, to proceed I can use recursion. Okay, so basically same string, right. That is all. So I'll increment the first by 1 and I'll decrement the last by 1. So this is not very efficient, right? I'd rather use a loop, but I mean, nonetheless. So this will of course only work for arrays because they are passed by reference, so their value will be retained. So just this thing, it's not a recursive call actually, but I mean, yeah, it's not a recursive call. I mean, since the same function is called inside itself, it is a recursive call, but it's not actually intending the purpose of recursion. So, but it will still do the job. That is what I want to say. It will still do the job. So this thing is there, max len. So same, I can just copy it from here. So print and scan is done, and yeah, here I don't need an extra variable because call by reference. So I will just yeah, I need the length of the string, right? So int strlen str. str is what I've stored, yeah, str, right? So this is done, and then I'll just call the function now. So the function was called sref again. String is str, comma. So 0 is the beginning, I mean where it starts, and len is the end. Len minus 1, of course, because len would be backslash 0. So swapping will be, wrong that way, and I can print the same thing. When I have, I'll just, why shouldn't I copy? Yeah, so I'll show you one more thing on the similar lines. This is not ref, this is str. Okay, so I'll run. Oh, I didn't initialize max len here. Sorry, I didn't define max len there, so yeah, my bad. So I'm not sure if you will get a chance to debug your code then, so during the examination. So just make sure to check thoroughly before you hit submit, as a general practice, I hope. Okay, so yeah, this is what it is. So yeah, wait, one more thing. So I just noticed one thing. So this previous code that was there, so here the error is I is undeclared, okay. It is not because of the lack of semicolon here. I just noticed that I forgot to put the semicolon. So just for your information. So now yeah, so now I'll just make the small change. I'll change this to end to see if it works, because end is a keyword, right? So end can't be, I mean, we are told that end can't be, but see here, when I write end, okay, so friend, so I'll make this also end. Yeah, see, end local. So I hope you can see below end in green text there is end local. That means end is a local variable, and it should not run if end is end is in quotes keyword end minus 1. Yeah, so string again. Okay, so it works. So and first you can make it maybe start or beginning or whatever. So basically you are pulling the end by 1 and pushing the start by 1. So this is like this method was just like for your information. If you feel that using pointers can be tricky because you are bound to make mistakes here, so that is why. Okay, so next problem very quickly, again pointers. Okay, so yeah, the chat is muted. What is the output of the following if size of int is 4, that you all know by now, and address of x starts at 4000. So 4000 is the memory location of x. So I have unsigned int 43, and I have 3 outputs. Okay, so what will be the output? start the timer for 3 minutes. After 3 minutes, I'll open the chat. You guys can answer, but I'll still give you 2 more minutes after that, of course, because total is supposed to be 5 minutes. So it's a basic question. So Okay, the timer went off. Okay, so yeah, let's see what the answer might be. So yeah, so it starts at 4000, right? Since x plus 3 I'm writing, and since I wrote plus 3 here, so it's not a mathematical operation where I add all, I mean where I add 3 to all the elements and then just do that, right? So, and it's unsigned, so x plus 3 is also basically its address again, right? So 4 3 as in it has 4 rows and 3 columns, this array. So 1 2 3 in one row, then 4 5 6 7 8 9 10 11 and 12. So x plus 3 would be what would be x plus 3? X plus 3 means I came to the fourth row. Yes, it is the fourth row. So I came to the fourth row. So I am at the beginning of the fourth row, right? So 3. So what will I multiply with 3, right? So to get to the fourth row, I have to cross 9 elements. Sorry, yeah, 9 elements. So first one, so I'll just write here, x plus 3 would be 4000 plus 3 into 9, right? Which is 40, not 3 into 9, 3 into 9 is 27. Just a minute. Integer value is 4. Sorry, size of int is 4. Total 9 elements. So 4036. Okay. So yeah. So first is 4036. Then I hope you understood how I got 4036. Since it's a 2-dimensional array, it is no rebuttals. So okay, fine. So since it's a 2-dimensional array, I'll this plus 3 would mean I'm increasing the row by 3, and since it's unsigned int, it means the address here, and this is also the same. Okay, this is also the same. So second one would also be 4036. And now third one, x plus 2. So I am increasing it by 2 rows. Then again I am increasing that row by 3, right? So each row has 3 elements, 3 columns. So this means the same thing again, right? So since it has 3 elements, this means the same thing. So I'll get 4036 again. So instead of 4026 or 4024, it should be 4036 3 times. Okay, so yes, that's what it should be. Yeah, so this one, right? So this one again. So this is, oh god. So what is this? This is basically 4000 plus 2 into 3 into 4, right? Because 4 is size of int, 2 is 2 because this 2, and and when we use pointers we have scaled addition, right? So and 3 is the number of 3 is number of rows in number of columns in each row, plus 3 into 4, right? 3 is this, and into 4 here and here are the scaling factors. So 2 into 3 plus 3 is 9, 9 into 4 is again 36. So 36. So I get 4036 again. Okay. Any doubt with this? If there are no doubts, I'll move to the, can you explain the last one? Yeah. So last one is writing the second one in a slightly different way, or even the first one in a slightly different way. So oh, you asked 1 minute ago. Okay. Anyway, so see, second one, I'll first explain second one. So last one is basic. See, second one is x plus 3, and last one is this, right? So I star is considered at the end, so don't worry about that. This and this mean the same thing. So so this x plus 3 would mean, this would mean 4000 plus 3, right? So 3 means I am traversing 3 rows. So I have reached the 4th row, right? I have reached the 4th row. So 3 rows means how many elements? Each row has 3 columns, so 9 elements. 9 into 4, because size of int is 4, that is why. So I got 4036. So using the same logic, when I write plus 2 plus 3, so here since 3 is after this is per element, okay. Yeah, so one small mistake, yeah, so I made brackets here, right, like this. So this does not mean the same thing, of course, else it is basically x plus 5, right? So this does not mean the same thing. So this, since this is in bracket, that means I am jumping rows, right, whole rows. But if I don't do that, if it is outside, then I'm only jumping element wise, okay. So x plus 2 would mean I've reached the 3rd row, right? I have jumped 2 rows, so 4000 plus 6, right? 6 into 4, because 1, 2, 3, 4, 5, 6. I am here. This is there. Now I am jumping 3 elements, not 3 rows. I am only jumping 3 elements. So that is 3 into 4 again. So this would be 4036. Was it like somewhat clear? Sudipta Sarkar, give a thumbs up, or you can say yes in the chat, so that I can proceed to the okay, I'll proceed to the next one. Okay, I don't think I'll be able to do this in this class, because this whole thing would need me at least 1 hour. So, but I'll still explain what it is in a minute. I mean, I'll take 1 minute to explain what it is, then you can try it out on your own. So there are 2 types of lists. One is a stack and one is a queue. So stack, we saw that how in recursion and all. Okay, so recursion is different. So stack means I have a list or an array where if I want to add an element, it will go to the end of the list or the array, and when I want to remove an element, so my element, so my array is 1, 2, 3, 4, 5, okay, and it is in some it is in some dynamically allocated part of memory, okay, 1, 2, 3, 4, 5, and I want to add or insert an element. It's called push, okay. So I want to insert an element 6. So my new thing will be 1, 2, 3, 4, 5, 6. So it will be inserted at the end. It will be pushed at the end, okay. Then when I use a function called delete, where I want to delete something from my stack. So it is not like I can say I want to delete this element, this particular element. It's not like that. It's basically I'll say just delete, and it will delete the last element. So the stack, so it will remove 6. So I gave this example again. So stack is, let's say you are making chapatis at home, and you store and you make like 10 of them and you put them in a vessel. So first one will be at the bottom, last one will be at the top, but when you will serve, you will take the top one first, the last one first. So this is first in and last out. So the first one goes out at the end. Okay, so when I delete the lastly added element, but queue, like the name suggests, it's like a queue, first in first out. So it is not like that. It's like queue or a line where you stand at the fast food chain or some library or a bank, wherever. The person who enters the queue first leaves the queue first. Okay, so if my array is 1 2 3 4 5 and I want to insert a number 6, so the new array is 1 2 3 4 5 6, and when I run the delete function, it will remove 1 and not 6. So the new array will be 2 3 4 5 6. Okay, so the memory allocated to 1 would be destroyed, but in case of stack, the memory allocated to 6 would be destroyed here. So that is why it is like dynamic, so it is moving in space kind of. Okay, not space, it is moving in memory. So there are many functions to insert. It's called add queue, dequeue, something, right? Then I can also search. I mean, search as in check if some element is there or not, and I can display the current size. So if my queue has like 10 people have joined and 2 have left, so it is plus 8. So I start with 0 size and empty queue anyway, but I can display the current size. So back to back I can keep on calling these functions. So what I wanted to do was just call these functions randomly again and again, and of course there will be one key that you have to press to stop it, to exit thing, to reset everything. But now I think it will be unfair of you to ask to do this. So yeah, and I can also display the current leading element in the queue. So the technically first element. So if I delete 1, then 2 will be the first element, right? So like that. So leave this. So you just try this later. But recursion, you need more practice with recursion. So write a function. So you know GCD and all, right? Calculate HCF using recursion. So write that function, and you have to use that function to calculate the LCM of same number. So what is LCM? Lowest common multiple. Okay, so this function, this GCD function or HCF function, for that you will use recursion. I hope you know the Euclidean algorithm, and then you will use that function to find LCM. Okay, so LCM, for those who don't know, it is lowest common multiple. So a number that divides both the numbers. So if I have 4 and 6, their LCM would be 12, because 12 is multiple of both 4 and 6, and there is no number below 12 that is a multiple of both. Okay, so this is fairly easy. I think 12 minutes should be enough. After 10-minute mark, I'll ask you if you've completed it, and if enough people have completed, I'll just stop the timer then and there, and then we'll see what to do. So someone has written the whole code here, so good, I guess. I will close this one. So only the first line is needed, then I can define int so this is a prototype. So first I would just I'll differentiate the larger one and the smaller one. So if A less than B, then I'll swap them. So this is one way to swap without temp. So I want the larger one to be A. Okay, so just for, and I'll just call so printf the LCM of the two numbers is I'll have to obviously write the actual functions. Yeah, so I didn't really have to write a function for LCM, but I'll just do that just for the sake of it. So int HCF, int A and int B. So, and I know that I know that A is greater than B, of course. So I can also write like non-zero numbers here, but yeah. So recursively I have to check. So if B becomes 0, then I'll return B, else return HCF. Okay, wait. Yeah, so this should work for GCD. I think even okay. B is 0, return A. I guess that also works. So but anyway, so yeah, and also same for LCM. Int LCM. So here I need not write a whole function, but I'll just return uh, so here I should just return like it was, like someone wrote, A by B by HCF of A and B. Right. So I'll run. Yeah, so here oh god.
Sir, written you cannot change, sir.
Return what?
You cannot change, sir. LCM.
Yeah. I cannot change as in?
Written, sir, written.
Yeah.
HCF. Good.
Yes. So this is still fine. Replace this first.
Sir, line number 36.
Line number 36. Yeah, what is there in line number 36?
41, sir.
Yeah.
It should be HCF.
Oh God, oh God. Okay, I understood. So many typos. So 4 and 6, it should give me 12. So, I mean, the logic behind this is pretty simple. So, if I have 4 and 6, so or I have, let's say, 15 and 20, right? So 15 and 20 are there. So their HCF is, so their LCM is 60, right? So 15 into 20 is 300 and HCF is 5. Their GCD is 5 and GCD is 5 and so 15 into 20 is 600. By 5 I'll get 60, not 600, this is 300, sorry. So this 60, so that is the HCF. So this is one way. Another way you can write this is without invoking HCF. So you can just but it is faster if you do this, because you can just keep checking numbers one by one, and if both the remainders, I mean if the remainder with both the numbers becomes 0, then it would be the LCM. So that is one way you can do it. So this is I think I made a lot of typos here, so that is quite, I mean, not really good. And okay, so final question. I hope this was clear. I have one more thing. Yeah. So last one is also recursion. This I think it was also part of some week's assignment. I mean, even before recursion was taught, just because when function started, just because we calculated the factorial using recursion, this problem was given. So I'm sure you know how to do this, but these might be a few things that might be asked in your exam. So just practice these things, and also you should be able to find the output of lines of codes. So snippets or whole codes, whatever. So snippets is just a bunch of lines. So you don't expect it to have hash include this, that, and all. Just part of a code. So you have to analyze and evaluate that, and just do that. So I hope the preparation is good. This I'm sure you can try it out. I mean, most of you must have done it already. So, but the logic is similar to what we did in reversing a string. So yeah, so you have this queue using array. Okay, void enq dq and display. So yeah, enq is basically to add something to the queue. So I mean, just look at the chat. Sudeepta Sarkar has written the code for queue. So not the whole code is, I mean, other things need to be printed. So the proper terminology for stacks is push and pop. So to enter a new element, it's called pushing, and popping out. So the top one will get, or the last one will just get popped out when you have to remove or delete. here it's called NQ and DQ. So NQ is adding more to the queue and DQ is removing it from the queue and then displays there. So how do I find without calculating the HCF? Yeah, that you can find. So so instead of so the longest possible method for finding the, can I get NPTEL previous year question paper? It is online, so you have to contact the NPTEL team for that. So I hope you are aware of forum in NPTEL. So you just ask there or you directly mail them. If they can share, they'll share. Yeah, and for Praveen, so the longest possible method would be to just starting from the bigger number, just checking if each number is divisible by both. So that will take a lot of time. Okay, and till you reach a number that divides both, not divisible by both, that divides both. So you can do that, and wherever and you can find, you can put an exit condition where, I mean, you can just run a while loop or a for loop with, which is, I mean, which needs to break out, which doesn't have natural breaking. So for loop that doesn't have natural breaking would be, let's say I start with I equals 1, I greater than 0, instead of writing I less than some value, I'll write I greater than 0 then I plus plus. So it will never naturally break out of the loop, you have to put a stop condition. So that way when you reach that number that divides both, you will reach your answer. Slightly faster way would be, instead of going through all the numbers, just go through the multiples of the bigger number. So if I have 15 and 20, I'll start checking 20 first, not a multiple, then I'll go to 40, I'll check, no, and yeah, so I'll check the multiples of the bigger number and only check if the smaller one is divisible or not. Okay, so with blindly increasing, I had to check for both. Now I have to check way less numbers and I have to check for only the smaller number. So in this, so in the first one, worst case would be I have to run that loop for a into b times. So if I have 15 and 16, their LCM is 15 into 16, that is 240. So I'll have had to run that 240 minus 16. So those many times, 224 times, right? 224 times. But here, with the second thing in mind, I have to run that 15 times. But if I know the LCM, so if I use HCF for that, I know that the HCF is 1. So I'll straight away I'll do 15 into 16 and I'll get the answer. Okay. Yeah, but calculating the HCF, that would take many iterations, because first I'll have 15 and 16. Okay. No, wait. Its modulo will be 1, right? So my next iteration itself would be 15 and 1. So that would give me the HCF straight away as 1. Okay. So by using recursion, time complexity will be less. It's actually up to you to think, because sometimes recursion can increase. Oh yeah, the time complexity will be less, correct. But sometimes recursion can increase the storage complexity. So I gave an example, and I think when recursion was taught in week 12, even the professor gave the example of Fibonacci series. So if I need the 10th element, I need 9th and the 8th element. But to get the 9th one, I need the 8th one, 8, 7, 6 and all. So I get all those. Then I do the same thing for 8. Although I have calculated that already, I still need the same, I have to do the same thing again. So that is wasting my storage space, right, and computational power. So recursion is not always good. And yeah, so all the best for your final examination. I think it is on Sunday. Can I get today's questions? I joined it. Okay, so I'll upload the presentation on the drive, and all the presentations are there on the drive, so you can just access it. I hope you have access to the drive. I mean the drive that I have created for this class. So after each class I upload it to the drive. So okay, how can I get this? NPTEL people would have shared the drive link. No?